All right, let's jump right in. Have you ever just stopped and thought about the incredible, invisible chemistry that's happening all around us every single day? Today, we're going to pull back the curtain on one of these processes, a transformation that happens to something you definitely have in your kitchen. It honestly feels a bit like magic, but trust me, it's all science. So, picture this. On one side, you've got liquid vegetable oil. It's pourable, it's fluid. And on the other, you've got a solid fat, maybe something like ghee. It's spreadable, it's firm. A lot of the time, these two start out from the exact same plant source, but they end up worlds apart. So what's the deal? What is the secret that turns one into the other? And that right there is the big question for this whole explainer. How in the world does a liquid oil become a solid fat? It's a transformation that has had a huge impact on the food we eat, and the answer? Well, it all comes down to one really powerful chemical reaction. And here's the name of that magic trick: catalytic hydrogenation. I know, it sounds super complicated, like something straight out of a chemistry textbook. But I promise you, by the time we're done here, it's going to make total sense. We're just going to break it down piece by piece.
So the official definition calls it an addition reaction. And honestly, that's the key. It's exactly what it sounds like. We are simply adding something to a molecule to completely change it. To really get it, let's just split that big name right in two. First up, hydrogenation. This part's pretty easy. It literally just means we're adding hydrogen. Specifically, we're using dihydrogen gas, or H2, which is just two tiny hydrogen atoms stuck together. That's it. That's the main event.
Okay, and the second part? Catalytic. This is just telling us that the reaction can't happen all by itself. Nope, it needs a helper, a chemical matchmaker, you could say. And that little helper is called a catalyst. Its whole job is to make the reaction happen way faster. And the cool part is, it doesn't even get used up in the process.
So, if we think of this whole thing as a recipe, what are the key ingredients we need to get started? Turns out, you only need three main things to make this transformation happen.
So here's our chemical recipe. First, you need a starting material, an unsaturated hydrocarbon. Now in chemistry, unsaturated is just a fancy way of saying a molecule has some double or triple bonds. Think of those bonds like empty parking spots, just waiting for something to pull in. Second, our main ingredient, that dihydrogen gas we just talked about. And third, our special metal catalyst to get the whole party started.
And not all catalysts are created equal. You can use a really fancy one, like platinum or palladium, and the reaction will just cruise along at room temperature. But when you're doing this on a massive industrial scale, you're probably going to use something cheaper, like nickel. The catch is, with nickel, you got to crank up the heat and the pressure to really get the job done.
Okay, we've got our ingredients. Now let's get into how this reaction actually works. The entire goal here is to take that unsaturated molecule and make it saturated. We're basically going to fill up all those empty parking spots we mentioned.
So here's how it goes down. You start with your unsaturated molecule, the one with the double or triple bond. Then the catalyst steps in, and its first job is to break apart the hydrogen molecule into individual atoms. Those hydrogen atoms then get added right across that double or triple bond, filling it in. And what you're left with is a brand new, saturated molecule that now only has single bonds. Its whole structure is changed. Let's look at a super simple example. On the left, we've got ethane. You see that little double line in the middle? That's our double bond, our empty parking spot. We add some hydrogen with our catalyst, and boom, we get ethane on the right. The double bond is just gone. It's been replaced by single bonds, and now the molecule is completely full. It's saturated. So, okay, that's the chemistry. It's pretty neat. But what does a molecule called ethane have to do with the oil sitting in your pantry? Let's bring this all the way back to where we started. Let's go back to the kitchen.
And here's the thing, this is not just some cool trick that chemists do in a lab. No way. Catalytic hydrogenation is a massive industrial process. It happens on an absolutely enormous scale, making things that we all use every single day.
And there it is. That's our answer. The unsaturated fats in liquid vegetable oils are the starting material. They get put through this catalytic hydrogenation process, which saturates their molecules, and that saturation is what physically changes them from a liquid into a solid fat. It is exactly how products like solid vanaspati ghee are made. And because it's done on such a huge scale, that cost-effective nickel catalyst is almost always the one they use.
So from a simple liquid oil to a useful, spreadable solid fat, all thanks to adding a little hydrogen with the help of a catalyst. Pretty wild, right? This one chemical trick has totally shaped huge parts of our food industry.
Which leaves me with one last question for you to think about. What other everyday items do you think are hiding the secret of catalytic hydrogenation?